Determine the coordinates of the vertex and the focus, equation of axis and directrix, and the length of the lattice rectum of the parabola whose equation is given to us. Let us begin. So we'll start with the given equation of the parabola. Here we have y squared plus 4x plus 4y minus 3 equals to 0. We're going to keep y squared plus 4y on the left hand side and transpose 4x and negative 3 to the right hand side to get negative 4x plus 3. Fine. We'll try to make y squared plus 4y a perfect square. So y squared plus, now 4y can be expressed as a multiple of 2. So here we have 2 times y times 2. And this number 2 tells us that we need to add 2 squared to it, which is an extra term that we're adding. So we need to subtract it as well. This will be equals to negative 4x plus 3. So y squared plus 2 times y times 2 plus 2 squared, this will be equals to, so negative 2 squared will be 4, negative 4, we'll transpose it to the right hand side and combine with positive 3 to get 7. Now y plus 2 whole squared, that's the expansion of the first 3 terms on the left hand side, this will be equals to, we're going to take negative 4 as the common factor, that gets multiplied to x minus 7 over 4. Now this is the equation of the parabola, but here the vertex has been shifted. So what we'll do, we'll try to make a substitution here. So let's say x minus 7 over 4, let this be equals to x. And y plus 2, let this be equals to y. So this is a substitution that they are making here. And this is going to convert equation number 1 to y squared equals to negative 4x. Now this is a parabola which is expressed in the standard form y squared equals to negative 4ax, where the value of a corresponds to 1. So we're going to use this value. Now what we'll do, we'll try to understand the graph of y squared minus 4x. Now this is a parabola which is left facing. So here we have the parabola y squared equals to negative 4ax. So here we have the parabola y squared equals to negative 4ax, and we are representing this parabola with respect to the new coordinate system x and y. Now for this particular parabola, the vertex is always going to be at the origin 0, 0, and it is going to be a left facing parabola with the coordinates of the focus at negative a, 0. Then the equation of the directrix will be x equals to a, since it's going to pass through the point a equals to 0. We also have the axis of the parabola, which is going to be the x-axis in our case, and that's given by the equation y equals to 0. And then we have the lattice rectum, it's the straight line passing through the focus and perpendicular to the axis of symmetry and its endpoints on the parabola. Now for our case, we have obtained the a value is equals to 1. So that means y squared will correspond to, y squared will be equals to negative 4x. Our vertex is going to be at 0, 0. Coordinates of the focus will be negative 1, 0. The equation of the directrix will be x equals to positive 1. The axis of symmetry is going to stay as y equals to 0. Then we have the length of the lattice rectum. So a value, that's 1. So that means our lattice rectum length will be 4 units. Now what we have is the new coordinate system that we have expressed our parabola. So in the new coordinate system, we have x, y. However, we want to revert back to the old coordinate system, that means in terms of x, y. Let's start with the vertex of the parabola. So here we have the vertex of the parabola according to the new system at 0, 0. This means that the x value is 0 and the y value, that's 0. However, in the old system, what we'll do, we'll replace this x value with x minus 7 over 4. So if we use this equation, x equals to 0, in place of x, we are replacing with x minus 7 over 4, that will be equals to 0, which gives us the value of x as 7 over 4. Then similarly, we have y equals to 0. So here we'll replace the value of y with y plus 2, so that will be equals to 0. Giving us the y value is equals to negative 2. So that means the coordinates of the vertex will be at 7 over 4, negative 2. This is according to the old coordinate system. Now let's move on to the focus of the parabola. The focus of the parabola is at negative 1, 0, which means x value is negative 1 and the y value, that's equals to 0. Moving on to the old coordinate system, x equals to negative 1 means x minus 7 over 4, that's equals to negative 1. So solving for x, we're going to get 3 over 4. And then we have y equals to 0. That means y plus 2 equals to 0, giving us y equals to -2. That means the coordinate of the focus of the parabola with respect to the old coordinate system will be 3/4, comma, -2. Then finally we have the equation of the, next we'll try to find out the equation of axis of symmetry line. So the equation of axis of symmetry line is defined as y equals to 0 when you go to the old coordinate system. So y is going to correspond to y plus 2, that will be equals to 0, which implies y equals to -2. This is going to be the equation of the axis. Then we have the equation of the directrix of the parabola. The equation of the directrix, we have obtained it as x equals to 1. So in the old coordinate system, in place of x, we replace with x minus 7/4. This will be equals to 1. So solving for x, we get x equals to 11/4. So that's going to be the equation of the directrix. And coming to the latus rectum, the length of the latus rectum, length of LR, with respect to the new coordinate system, x comma y, the length of the latus rectum came out to be 4 units. Now, in respect to the old coordinate system, it's still going to stay as y, because the shape of the parabola is remains unchanged irrespective of the coordinate systems that we are using. So hence we have successfully obtained the vertex of the parabola. That's going to be at 7/4, comma, -2. The coordinates of the focus will be 3/4, comma, -2. Y will be equals to -2, which gives the equation of axis. The equation of directrix will be x equals to 11/4, and the length of the latus rectum will be 4 units.